are now on to 1.6. So this call is going to cover 1.6. 1.5, remember we talked about, let me pull up my notes here. In 1.5, we talked about combining functions together, right? So it looked complicated, right? We were adding functions together, subtracting them, multiplying, dividing. It looked complicated, but then when we actually did it, wasn't too bad, right? All right, so the second thing that we talked about was kind of at the end where we composed two functions together. So remember, this is when it looked like fog, but it's not fogged. It's f composed with g, which is basically when you take f of g of x. So you're putting one function into the other function. Okay.
I can't see any of the notes on the screen.
That would be helpful if I share my screen. Is that better?
Yeah.
Okay. Thank you for telling me that. I appreciate it. All right, so we basically are putting one function into the other. And there's this kind of cool little picture over here that shows you what fog is, f composed with g is. Okay, so basically what the domain for g is x, and then you're putting that g of x domain into f, and then you're composing those together. I don't know if that helps you or not, but that's kind of a visual of what's going on. So this is important. Why I'm kind of reiterating 1.5 is because it directly leads us into 1.6. Yay. All right, so 1.6 is inverse functions. Okay, so inverse functions. So what inverse functions are two functions that are inverses of each other. Sounds like a very simple definition, right? So what this looks like is this. If you have a function, f of x equals x plus 4, the inverse of that function is the inverse of f of x is x minus 4. Okay, so for our original function, the domain of f, okay, we have the domain of f is x, and the range is f of x. All right, and then in our inverse function, basically what we put in is we basically switch what we put in and we put out. So again, I'm not sure if this picture helps or not, but in the inverse function, the domain of the inverse is actually your range of your original equation. And what you get out is the domain. All right, so let me take a look at this another way. So we have f of x equals x plus 4, and f of negative, or f inverse of, the inverse of f of x is x minus 4. I totally can talk today. So let's look at this a different way because it's a little bit weird to think of, but let's pull up Desmos, right? So we have, this is a very simple inverse. F of x equals x plus 4, okay? And we have f, I don't know if I can do the inverse, so we're just going to call it g, just so you know that it's different. G of x equals x minus 4. Okay, these guys are inverse functions of each other. So if I turn each of these into a table, let's see if I can get them both here. Where we go. There we go. All right, so you can see here that in my original function, okay, if I put in, I'm going to manipulate this a little bit. Nope, 3. Okay. If I put in my original function, x equals negative 3, I get out f of x equals 1. In my inverse function, if I put in x equals 1, I get out negative 3. So can you see in an inverse function that basically the domain and the range interchange with each other? Okay, so let me see if I can find another one. If I put in, Kind of have to manipulate my data here. Well, okay. So if you put in x equals -1, right, you get out f of x equals 3. If I put that in my inverse equation, if I put my range, which is 3, in my inverse function, so I put 3 in, then I get out -1. So your functions are inverses of each other. Basically, if the original equation or original functions, domain and range, are flipped in the inverse. Okay. Does that make sense or not? That's kind of the general definition of inverse functions, that you're basically flipping the domain and the range. If you're able to flip the domain and the range, that means they're inverses. You guys feel comfortable with that? Anybody still here with me?
Yeah.
All right, cool. Mackenzie's with me. All right, really quickly, I need to invite Daniel back again. Daniel Watson. Shadow. Let me see if we can get Daniel back in here. All right, there we go. Yeah, it's good. Okay, so that's what an inverse function is. Now, the technical definition is that the technical definition of an inverse function is that if you have a function f and g, that if you have f of g of x equals x and g of f of x equals x for every x in the domain, then these functions, g and f, are inverse functions. So, and g is denoted by f with this little -1, which means f inverse. So basically, two functions are the inverses of each other when you compose them together both ways if they equal x. Okay, so that was just a whole bunch of words, but basically in our very simple example that we started off with, this is what it means. Where's my pen that I can write with? Here we go. So again, going back to our, these two guys, right? So f of x equals x plus 4, right? F of x. G of x equals x minus 4. I already showed you that they're inverse functions. It's obviously an example. But in order to prove that they're inverse functions, we need to prove that f of g of x equals x and that g of f of x equals x. And if these two are true, then we can say that they are inverses of each other. So really quickly, f of g of x, okay, f is x plus 4, right? X plus 4. And g is x minus 4. So when we combine those together, x minus 4 plus 4 just gives us x. So that's true, right? And then g of f of x is g, which is x minus 4. And instead we plug in f, which is x plus 4. And we end up with x plus 4 minus 4, which is just x. So then we know these are inverse functions. Okay. And the way that we say this is that we have f of x and we have the inverse of f of x. So we call this one f of x and this one inverse of f of x. Okay. All right. So that's that. That's kind of the general idea of what a function is. All right, back to the notes. Okay. So the graph of an inverse function. The graphs of a function f and its inverse, f inverse, are related to each other in the following way. In a point AB lies the graph of f, and the point BA must lie the inverse, or vice versa. Okay, so we talked about this on Monday as well. Basically, if you have f of x, which is this lighter color one here, and you have the inverse of f of x, then they're going to basically mirror each other, and they're going to reflect across y equals x when you graph any of them. So that's the reflection point. Basically, that's the point which makes them symmetrical, is across y equals x. And we'll practice that. And a couple other things. This is how we do it, so I'll show you that. But how do we find an inverse? But in order for a inverse to have an, in order for a function to have an inverse, well, I guess let me take a step back. What is that rule that we've talked about a couple times? How can you graphically show that something is a function? How do we know something's a function? It's the vertical line test, right? So something is a function. Something is a function. Sorry, I'm trying to write with my pen today. If it passes the vertical line test, right? Something is a function if it passes the vertical line test. Basically, anywhere you draw a vertical line, I should do those in different colors. Anywhere you draw a vertical line, you should only have one solution, right? That's the one-to-one. In order to have, and think about this, the inverse, okay, inverse is basically when we flip the x's and the y's, right? So the inverse of this parabola would look something like, I'm always terrible at drawing these. The inverse of this parabola would probably look something like this, I think. I think it would look something like this. Anyway, the inverse of this would look like this. And so in order to tell if we have a inverse function, it also must be one-to-one. So instead of having a vertical line test for if it's a function, the test for the inverse of a function is the horizontal line test. Okay, does that make sense? Since we're reflecting the graph across y equals x, we're going from a vertical line test for a function to a horizontal line test for the inverse of a function. Okay. And that's in your notes. If you have the second page, what it says is the first step to finding the inverse of a function. How do you find the inverse of a function? Use the horizontal line test to decide whether f even has an inverse function. Okay. And then we talk about the steps how to actually find the function. Okay. And we'll go through each of those steps. All right, so let's do some problems here. We got some fun ones to do. Let's kind of start off just warming up finding inverses and what we do with those, okay? So it says in 1 through 8, find the inverse function of f informally. Verify that f of the inverse of f of x equals x, and the inverse of f of x equals x. That's a mouthful, right? So it says to do it informally, but I'm just going to go ahead and show you the the steps that it has and how we actually go about finding the inverse. Okay, so and I should have copied this down with my notes, sorry. Well, it's in the box above here. So for example, if we want to find the inverse of number 2, okay, so number 2 is f of x equals 1/3 x. Okay, so this is a line, so it's going to have an inverse, right? You know 1/3 x when you graph it is like a line, right? It's going to have an inverse. It passes the vertical and the horizontal line test. Lines always do that, right? So the way that you find a inverse function, step 1, if you look in the box above it, says use a horizontal line test to decide whether it has an inverse. That's true. Okay, so what you're going to do is you're going for the step 2 is for the equation f of x, you will replace f of x by y. So y equals 1/3 x. Okay, that's the first step. Now you're going to switch x and y. So now you're going to say x equals 1/3 y. That's step 3. Okay, and in step 3, and this is the box above it, step 3, then you're going to solve for y. You're going to solve for y. So in order to get y by itself, I'm going to multiply both sides by 3. So 3x equals 3 times 1/3 y. 3, okay, or y equals 3x. Okay, then step 4 of finding an inverse is to change your y to the inverse of f of x equals 3y. Right, so now we have solved. This is our function. Okay, this is our inverse. All right, and then in order to prove that they're inverses of each other, we have to put one into the other. That's how you prove that they are inverses. Okay, so you would say, what is, and this is kind of a quick thing you can do. What is f inverse of f of x? So it's 1/3 of 3x, which is x. Oops, I'm off the screen. I can't get my screen to move over here. Where's my mouse at? There we go. That equals x. Okay, and then the inverse of f of x would be 3 times 1/3 x, which is x. All right, so that's a pretty easy, pretty straightforward thing, right? Let's do a little bit more complicated one. Let's look at maybe number 10. Okay, so number 10 says, show that f and g are inverse functions algebraically and use a graphing utility to create a table of values for each function to numerically show that they are inverse functions. So is everybody, first of all, is everybody tracking so far? A lot of information from early in the morning, right?
Yeah, I got it.
Cool. All right, so let's do some little color coding here. So we're going to do number 10. Let me move my computer so maybe I can write a little better. All right, so number 10 is that, oops, that's not what I want to do. Back to that. Number 10 is f of x equals x minus 9 divided by 4. Okay, and g of x equals 4x plus 9. Okay, and we want to show that they are inverse functions algebraically. So in order to do that, we have to basically prove that f of g of x equals x, and g of f of x equals x. That's how we algebraically show that they are inverses of each other. Okay, so f of g of x looks like this. F of g of x is sum x minus 9 divided by 4. Okay, but instead of x, right, I'm going to put in 4x plus 9. Okay, and then when I go to solve this, it's 4x plus 9 minus 9, which is just 4x over 4, which is x. So that checks out, right? And then I do the same thing for g of x. And spoiler alert, that's going to check out. Now, the second part is use a graphing utility to create a table of values for each function to numerically show that f and g are inverse functions of each other. So if you have Desmos, what that's going to look like is, I kind of did this at the beginning. Got to get to Desmos. Okay. So you can enter your functions in. So we have f of x equals x minus 9 divided by 4, right? And we have g of x equals 4x plus 9. Okay? And these are the two inverse functions that we showed, right? Just to kind of show you, remember inverse functions always vary by y equals x. So can you see, here is y equals x. Can you see how they basically reflect across y equals x? Pretty cool, right? All right, so now if you want to use the table function in Desmos, what you do is you go up to Edit List, and then there is a Convert to Table function. Okay, and then again, Edit List, Convert to Table. So for example, you can see here that if I put in x equals 1, my f of x is negative 2, right? But if I put in x equals negative 2, my g of x is 1. All right. And so I just want you to explore that in your homework. I don't need you to copy down the answers from here, but for those problems, I just want you to kind of explore that. Okay. What else did I want to tell you about this? I think that's it. Oh, if you're using, I know what I wanted to tell you. If you have your TI calculator and you want to have the table, you're going to go into y equals, and you're going to put in your two. One is going to be y equals 1 and y equals 2. Okay. And then you can hit your graph button, but above the graph button, there's a function that says table. So if you hit second graph, that will actually give you the table of these values as well. So you'll be able to see those in there. That's how you would do that. Okay. I want to graph another one just because I think it's more interesting. I'm going to graph number 14 on your paper. Just so you can kind of get a cooler graph than what we've got here. Because so far all we've done is graph lines, right? So number 14 is the cubed root here we go. The cubed root of 3x minus 10. Okay. And then we have g of x is x cubed plus 10. And this whole thing is divided by 3. So make sure that you get your functions typed in correctly, right? Okay, here we go. So and then I'll put my y equals x in here. I got to zoom in a little bit to get the coolness of it. So this is just number 14. I just want to show you graphically. This is another inverse function. It's kind of cool, right? This black one is your original function and the red one is your inverse function. And you can see again that they reflect across y equals x. Kind of cool looking, right? Okay. Let's see. I'm trying to decide what I want to do next. I'm gonna pull out one of your homework problems. Let's do one of your homework problems just to kind of keep practicing. So if you have your notes with you, make sure that you're kind of tracking along here. I'm going to pull up section 1.6. And just so you know, this is our last section in 1. So, okay. Okay, so let's do homework problem number 17. I'm on page 69. Oh, don't save, don't save. Where's my pen at that I'm writing with? All right. Sorry, guys. I'm trying to find, I sat my pen down some. There it is. Okay. So number 17, if you have your book, we're on page 69. It's the bottom left. And it says f of x equals the square root of x minus 4. And g of x equals x squared plus 4. And then it says x is greater than or equal to 0. And it says, show that f and g are inverse functions algebraically. Use a graphing utility to graph f and g in the same viewing window. Describe the relationship between the graphs. Okay, so again, just more practice kind of doing what we're doing. This is number 17. Okay, f of x equals the square root of x minus 4. Okay, and g of x equals x squared plus 4. And it actually tells us x is greater than or equal to 0. Okay, so that actually has to do when we get to graphing in our domain and our range. Okay, so if I want to show that they are inverses of each other, I need to show that f of g of x equals x and g of f of x equals x to prove that they are inverses of each other. Okay, so let's start with f of g of x. So f of g of x means that I am taking the square root of x minus 4, right? But instead of x, I'm going to use g of x. So it's x squared plus 4. Okay, so x squared plus 4 minus 4 is just x squared. And the square root of x squared is x. So that checks out, right? And then I have g of f of x. Okay. G of f of x means that I have x squared plus 4. And for my x, I'm putting in the square root of x minus 4. So x minus 4 square root squared is just x minus 4 plus 4, and that equals x. So again, I can prove that they're inverse functions, and then if I go to Desmos, or my graphing tool. Use a graphing utility to graph f and g in the same viewing window. Describe the relationship between the graphs. Okay. So my f of x is the square root of x minus 4. And my g of x is x squared plus 4. Okay, and then here's my y equals x. So what do you notice about these graphs? If I zoom out a little bit. The black and red graphs are my two inverse, or my function and my inverse, right? The red inverse function actually looks like more data than my black original function, right? But if you remember, they state that g of x is the inverse only when x is greater than or equal to 0, right? And it does not like that I typed it in like that. I always mess up. How do we put that in there? Maybe some brackets. Let's see. I think I got to use the fancy brackets to put that in. There we go. Oh, yeah, I got it to do it. Okay, so g of x is only valid as a inverse when x is greater than or equal to 0. Okay, and this restriction on our g of x is what makes it able to be an inverse of the function. Okay. So not too bad, right? All right. Not too bad. I'm just looking at my problems, what I want to do next. I think you can probably figure these out. Determine if the graph is that of a function. If so, determine if the function is 1 to 1. So determine if the graph is a function. Determine if it's 1 to 1. So basically on those problems, you're just going to be looking at the graph. So what do you think? Is number 30 a function? I say yes, that's a function. Is the inverse a function? That I don't know because I don't have that data there, right? What about number 32? Definitely a function, right? Okay, so then let's skip down a little bit. And 35 through 46, it says use a graphing utility to graph the function and use the horizontal line test. Oh, I see what they were saying. Sorry, back in 30. Let me back up a little bit. Number 30 is a function, right? The inverse of number 30 would not be a function, right? Because it doesn't pass the horizontal line test. Sorry, that's what I meant to say there. But what they're actually asking is it a function? So I would say that number 30 is a function, but the inverse is not a function. If that makes sense. Okay, so number 36 through 46, it says, use a graphing utility to graph the function and use the horizontal line test to determine whether a function is 1 to 1 and so has an inverse function exists. Okay, that was like a fancy way of saying that. But basically what you're going to do for these is we're going to take our functions. So for example, number 36, and we're going to graph it. Okay, so let's graph number 36. which is f of x equals, and this is going to test out your graphing skills, 1/4, right? X plus 2 squared minus 1. Okay, so there's my parabola again. All right, same as the other one, right? So is the original function that's listed, is that a function? Yes, right? Everybody okay that that's a function? All right, there we go. Greta says yes. All right, what about, is there an inverse function? What do you guys think? No, there's not an inverse function, right? Not an inverse function because it doesn't pass the horizontal line test. Okay, so let's try number 40. I don't know what 40 is going to be. I haven't looked at that one yet. -2, -2x, the square root of 16 minus x squared. Oh, this is a crazy looking one. It's kind of a cool one, right? Okay, so does this pass the vertical line test? Yes, so it is a function. Does it pass the horizontal line test? No. So is this a function? Yes. Is it a function that has an inverse? No. All right, so that's all you're going to do for those last few problems. So not too bad. The trickiest part is just remembering how to put one function into the other, I think. But not too terrible. So as always, when you look at the beginning, it's like, but it's really not too bad. I'm trying to think if there's anything else I want to cover with you, just to make sure that we got everything in since we have a couple minutes. Oh, I know. I'm not being super clear on that. So let me make sure that I'm saying this right. That's the last thing I want to make sure that I go over. So this idea that, back to number 30, okay? Number 30, as it's shown, is a function. It does not have an inverse, right? So you would say it is a function, but it does not have an inverse. It says, determine if the function is 1-to-1. So 1-to-1 basically means that that it has an inverse function. So the definition, I don't have it written out, is a function has an inverse function if and only if it is 1-to-1. Okay, so a function is 1-to-1 if it passes both the horizontal and vertical line test. So we would say that number 30 is a function, but the function is not 1-to-1 because it doesn't have an inverse. Number 32 also is a function, and it's 1-to-1, so it does have an inverse. So I just wanted to pick, because I see this terminology of 1-to-1 and 1-to-1. So the idea of 1-to-1 means it passes both the horizontal and vertical line test. Okay. And that is all I want to say about this section. Greta had a question about 1.5, so tell me which one that one is, Greta. So that means we're done with chapter 1. We're not doing 1.7. Go ahead so that means your homework will be due on Monday the 1st, and then I will send out the test, and the test will be due on the 8th. Okay. And then Greta had a question on 1.5, number 13. It says, I'm on page 58. It says in exercises 13 through 26, evaluate the indicated function for f of x equals x squared minus 1 and g of x equals x minus 2 algebraically. If possible, use a graphing utility to verify your answer. All right, so let's try this one, Greta. Okay, so number 13, we have this is number 13, and we are on page 58. Okay, so we have f of x equals x squared minus 1. And Greta, is there a particular spot that was like, or just the whole thing? Okay, whole thing. We'll do the whole thing. Okay, so these are our two functions. Just make sure I wrote them correctly. And then we want to find f plus g of 3. All right, so f plus g of 3. So before we evaluate the 3 part, let's just figure out what f plus g of x is, right? So we want to add the two functions together. We're going to add f of x and g of x together. Okay, f of x is x squared minus 1 plus x minus 2, right? So we end up with x squared plus x minus 3. X squared plus x minus 3. That is f plus g of x. Right? So now we want to figure out what happens when I put in 3 for x. So I'm going to put in 3 and 3 here. Right? So my f plus g of 3 would be 3 squared plus 3 minus 3. So 3 squared is 9 plus 3 minus 3 would give me f plus g of x is 9. F plus g of 3 would be 9. All right, so Greta, is that where you ended up, or you ended up a different spot? Okay, cool. I'm glad that makes more sense. Good practice on that. Hey, and guys, if you're working on your homework and you come up with any questions, just send it over to me, all right? And I hope you have a good rest of your day, and I'll stay on for a minute or two if anybody has any questions. Thanks, guys. Have a good weekend.